So today's lesson is going to be on our solar neighborhood. So in other words, we're just worried about the things that are inside of our own solar system, whether it's planets, whether it's the moons of those planets, whether it's asteroids, and anything else in between. So here we go. Again, like I said, focus for today will be on the solar system. Some questions that we'll have for today are, how did it form? So in other words, where did our solar system come from? Why does it exist? What is the sun? Seems like a silly question to ask, but we'll talk about what actually goes on in the sun. We've kind of learned a little bit about that before. What are the planets in the solar system and what are their characteristics? So you'll have to know a little bit about each one. We don't need to go in super great detail, but just a little bit about each one. And what other objects exist in our solar system. Here we go. So our solar system consists of the sun at the center and the 8 planets orbiting around it. It's believed to have formed about 4.5 billion years ago, and there's a lot of evidence for that. One of the key pieces of evidence is through a process called carbon dating, which basically means you look at the proportion of the types of carbon that exist within certain objects, especially rocks, and you can tell how old those rocks are. The oldest rocks we find in our solar system more or less tend to be around 4.5 billion years old. So that's kind of one piece of information that we get that from. Now, the presently accepted theory for the formation of the solar system is that a nebula, which is a massive cloud of dust and gas, okay, a big nebula all throughout the whole solar system where it is now, that used to exist where our solar system is today, began to swirl. So as soon as gravity started taking over in little clumps inside of this, it started getting some momentum because it started pulling some other things that caused it to spin. It happened over a very long period of time. Once the swirling motion started, this caused it to flatten into a disk. And then the gas and the dust clumped to form the sun at the very center and all the planets and little rings around it. One of the key pieces of information that tells us this is likely what happened is the fact that all of the planets in our solar system actually orbit around the sun in the same direction, right? If there were some things going one way or some things going in another way, that might indicate that something else happened. The other key piece of evidence is all the planets in the solar system are on the same plane. So imagine the solar system is a flat disk. Everything's on that disk. It's not like an atom where we have things buzzing all over the place. It's not like that. It's just everything going around in disks. Okay, so this is just a key theory as to how the solar system may have formed, and we can actually see by looking at things elsewhere in the night sky. We could potentially see from other nebulas their different processes as they develop into planetary systems like our own. Anyway, kind of cool. All right, so we're going to start with the sun in our solar system. Of course, it's at the center of the solar system because we now understand that the heliocentric model was true. Now, the sun is mostly made out of extremely hot hydrogen. That would be a type of hydrogen gas in a way. It actually kind of even becomes like a plasma. But anyway, we can call it hydrogen gas. The surface temperature, so right on the surface of the sun, is about 5,500 degrees Celsius. So obviously very, very hot. There are temperatures on Earth that we've been able to create in laboratories that are higher than this. But given that it's pretty consistent on the surface of the sun that we have temperatures that high, that is pretty incredible. Now, in the core of the sun, so the very center of the sun, hydrogen undergoes nuclear fusion to form helium, which, if you remember the periodic table, it's one above hydrogen on the periodic table, like it's the next one over. And this process releases an incredible amount of energy. Nuclear fusion is basically this gigantic nuclear bomb going off at all times. Now, the sun also releases charged particles that shoot out in all directions. They pass Earth at a speed of about 400 kilometers per second. This is what we call the solar wind. Now, the good news is with these particles, they don't usually really strike anywhere on Earth because Earth, of course, has a magnetic field. That's how our compasses work, of course. Earth's magnetic field is strong enough that it actually deflects these particles. Notice it said it was charged particles coming. So of course, if they have a charge to them, they're going to be either attracted or repelled by a magnetic field. As they get closer and closer to Earth, Earth's magnetic field changes the direction of them so that they don't come and hit the Earth, at least not as much as they would if it was straight on. If you've ever seen the Northern Lights, you're actually seeing the solar wind interacting with the magnetic field of Earth. That light show that it forms is just basically a reaction that's occurring way up in the atmosphere as these charged particles are interacting with our magnetic field. And that explains why, of course, the northern lights are mostly found, of course, at the poles, whether it's the North Pole or the southern lights would be at the South Pole. That's because, of course, that's the end zones of our magnetic field, right? So that's where most of that action is going to go. Anyway, moving on. Now, away from the sun in the center, of course, are the planets. Now, the planets in the solar system are categorized in one of two ways. We have the inner planets, the ones closest to the sun, And these are also known as the terrestrial planets. Now, the word terrestrial means Earth-like, okay, because it actually has to be based around like the word terre in there refers to Earth, right? So terrestrial planets are Earth-like. Then there's the outer planets. These are these guys out here. These are also known as the Jovian planets. That's a really weird word. Jovian means Jupiter-like, but more commonly we call them just the gas giants. It gets more straight to the point. So the terrestrial planets inside here, they're mostly made of rock, whereas the gas giants, the outer planets way out here, they're mostly made of gas. Now, the terrestrial planets are rocky. Oh, I just kind of said this, but they're also obviously a lot smaller than the Jovian planets. They're located closer to the sun, and the Jovian planets are mostly made of gas and are far larger than any of the terrestrial planets. Even the smallest ones are bigger than even the biggest terrestrial planet. The biggest terrestrial planet, just by the way, is Earth, barely. Venus is pretty close, but it's barely bigger. And they are, of course, located farther from the sun, hence the name outer planet. Moving on. Mercury, this is the first planet closest to the sun. Mercury's distance from the sun is 0.39 AU. So about 39% of what Earth's distance from the sun is. The radius, of course, that means from the center to the outside. The radius of Mercury is 2,440 kilometers. You won't need to memorize these. It's just nice to know that Mercury's size is this. You'll see how it compares with the other ones. Now, the surface temperature of Mercury is quite interesting. Mercury doesn't really have much of an atmosphere. So that means it's pretty much left open to whatever the sun is doing on the surface of it. When the sun is glaring on the surface of Venus, or sorry, on the surface of Mercury, the temperature during that daytime then would be about 400 degrees Celsius. So pretty comparable to what it is inside of your oven when you're cooking something. However, at nighttime, so on the other side of Mercury, when it's facing away from the sun, it's negative 180 degrees Celsius. Brutally, brutally cold. That's colder than any normal outdoor temperature on Earth ever, which is kind of weird because you'd think closer to the sun it'd be warmer. But again, it doesn't have an atmosphere, so that heat doesn't really have anywhere to stay. So as soon as it becomes nighttime on Mercury, that side of Mercury instantly, loses all that temperature. So Mercury is the closest planet to the sun. It's also the smallest in the solar system. That's kind of interesting that the smallest one's closest to the sun, but there's likely a good reason for that. Mercury has no atmosphere and faces no protection from the effects of the sun and asteroids, right? So we'll get into asteroids a little later today, but of course, asteroids oftentimes when they enter a planet's atmosphere, they'll burn up just from the friction as it's going through the air in the atmosphere. If it doesn't have an atmosphere, that's not going to happen. So if you look at Mercury's picture here, it's very heavily cratered. There's a bunch of little craters all over it. That's because, of course, asteroids over, millions, if not billions of years have pounded Mercury over and over and over again with very little protection. Basically, anything that comes into Mercury's gravity doesn't burn up and just ends up smashing into the ground, which is pretty crazy. Anyway, moving on. Venus, this is the second planet from the sun. The distance from the sun is 0.72 AU, so about 72% of what it is for Earth. So a fair bit closer to the sun, of course. The radius of Venus, so again, from the center to the outside of Venus, is 6,051 kilometers. So obviously much bigger than Mercury. It's over twice as wide as Mercury is. The surface temperature of Venus is a pretty consistent 450 degrees Celsius. You'll notice that's hotter than what Mercury's temperature is, even though it's much further away from the sun. The reason for this is Venus has an extremely thick atmosphere, and I can't understate this. It's hard for us living on Earth to even understand just how thick and dense this atmosphere is. The pressure of the air on Venus is 92 times the pressure on Earth. If you were to stand on the surface of Venus, temperature aside, you'd be crushed like a pop can. It would be so much pressure, you would just blow up basically from all that pressure. This is like comparable to pressure near the, or deep down in the ocean, right? After all of that water is pushing down on it. So this atmosphere of Venus, super, super, super dense. And that's why when we see this photo of Venus up top here, this photo is like, this is true color, right? So if you were to see Venus, if you were flying past the planet of Venus here, you wouldn't actually be able to see the ground because the clouds are so thick and so dense. Which is pretty crazy. Now, another crazy thing about Venus is if the temperature and the pressure weren't bad enough, the atmosphere is super toxic to life, right? There'd be no way we'd be able to breathe this, even if the pressure was normal pressure, because the atmosphere is a lot of sulfuric acid. So it does rain on Venus, but it doesn't rain water like it does on Earth. It rains sulfuric acid. That's the same stuff that's in battery acid. It's insane that this is happening on Venus. So this is a horrible, horrible place. Now, the USSR, that's the Soviet Union, they landed a rover on Venus in the year 1970. However, what was interesting about it was it only lasted a few hours before being destroyed, not only by the high temperature, but also the high pressure. They designed it as best they could, and they knew like something like this was going to happen, so they thought they'd make it as sturdy as possible. But even with the most advanced technology at the time, we couldn't build one that would withstand that terrible, terrible pressure. This photo right here, this is actually one of the Soviets' photos of the surface of Venus. So this down here is just the edge of their rover that they had land. But you can see it's a pretty horrible wasteland. You can also see, you can't really see very far in there, right? Like it's like there's a dense cloud of fog. That is because, well, Venus has a very dense atmosphere. Anyway, Earth. This one, of course, the distance from the sun is exactly 1 AU on average. That's what an AU was defined as. Remember, that means astronomical unit. I don't think I mentioned that earlier today. The radius of Earth is 6,378 kilometers. You'll notice that's just a little bit bigger than Venus. The surface temperature on average is 15 degrees Celsius. As we know, living where we live, of course, that changes rapidly. Now, this is where we get a new category that comes in here. Earth has a moon, right? It is the closest planet to the sun that actually has a moon. We're not the only planet in the solar system that has a moon, or not even close, as a matter of fact. But we do have a moon, of course. Now, Earth is also the only planet known to have life. That should be pretty obvious to you. Earth is the largest of the 4 terrestrial planets. So of the 4 innermost planets, we're the biggest. And most of the surface of Earth is liquid water. It is the only planet that has a liquid surface. Every other planet in our solar system either has a solid surface or, of course, a gas surface like our gas giants that we'll see in a moment. So most of Earth's surface is actually a liquid, which is pretty unusual in our solar system. So we're quite unique in many ways. Mars, this is the 4th planet from the sun. Mars's distance from the sun is on average 1.52 AU. So it's like the Earth's distance from the sun plus another half of that. The radius of Mars is 3,390 kilometers. So Mars is about half the radius of Earth. The average surface temperature on Mars is negative 63 degrees Celsius. So it is very, very, very cold. There are some areas, especially near the equator, where it warms up to a more reasonable temperature. But overall, negative 63 degrees Celsius is how cold it is. Now, the number of moons that Mars has is 2. They don't have moons that are nearly as interesting as ours. As a matter of fact, one, if not both of their moons, isn't even a perfectly round circle. As I draw something that isn't a perfectly round circle, their moons are more like oblong shape, right? So they look more like asteroids that are floating around it, but they technically do qualify as being a moon. The surface is coated in iron oxide. That's why it's so red. Iron oxide, if you might remember, is rust. It has 2 polar ice caps, one at the top, one at the bottom, of course, made of both water and carbon dioxide ice. So there is water on Mars. The atmosphere on Mars is carbon dioxide, so it's the same kind of stuff that we breathe out, but it's a very, very thin atmosphere. So it kind of has a similar problem as Mercury in some ways, in that it doesn't really have much of an atmosphere. At least it does have one. Mercury really doesn't have one much at all. Like Mercury is kind of comparable to the moon in that regard. But still, there is an atmosphere. It's just a very thin one. I think it's about 1% the thickness of Earth's, although you wouldn't be able to tell this from this photo. Now, 4 Mars rovers have visited the planet since 1997. That might actually be updated. I think there's been a couple other rovers. There was one not too long ago, so it might actually be more than 4. But still, several rovers have visited Mars, and I think a reason for that is the surface conditions on Mars are a lot easier for us to deal with than, for instance, Venus. And I think Mercury isn't exactly that interesting, but hey, maybe they'll put a rover on Mercury someday. Who knows? Okay, now we're moving into the outermost planets. We got Jupiter. Jupiter's distance from the sun is 5.27 AU. The radius of Jupiter, this is not a typo, is 71,000 kilometers. The surface temperature is negative 108 degrees Celsius. The number of moons that Jupiter has, it could be bigger than this because we seem to find one every other year. 79 moons buzzing around Jupiter. It's incredible just how many moons there are here. Now, Jupiter, of course, is the largest planet in the solar system. It's made mostly of hydrogen and helium, so it's made of the same stuff the sun is, which is quite interesting, right? And another big key feature about Jupiter is it has an Earth-sized storm called the Great Red Spot. So right here in this picture, that spot, which is a giant hurricane, basically, that's as big as Earth. Earth could fit in there. Crazy, right? Now, if Jupiter was a few times larger than it is now, it actually might have become a star. It has the exact same ingredients as stars have. If it was bigger and therefore had more pressure down in the core could ignite and become nuclear and use nuclear fusion and become a star just like the sun. So pretty crazy. Before we move on to the next planet, I want to talk about Jupiter's moons. Jupiter has 79 known moons, but 4 of them are notable. The 4 notable moons of Jupiter, here they are in this order. There's Io, that's this guy. There's Europa, there's Ganymede, and there's Callisto. Galileo, who we've talked about before, he actually discovered these moons. You can't see them with the naked eye, but if you point a telescope at Jupiter, you can actually see some little things buzzing around it. And these 4, being the biggest moons of Jupiter, were the ones that were easiest for Galileo to spot. Now, later space probes revealed that they are almost planet-like in their appearance and not boring, quote unquote, like our own moon. All 4 of these are pretty interesting to look at. They're all unique in their own ways. I mean, Ganymede's a little bit moon-like in some ways, but especially if you look at Europa, there's quite an interesting appearance to it, right? Io, by the way, is the most volcanic object in the solar system. This thing is covered in volcanoes and they're constantly erupting. Europa is fascinating because it's encased in water ice. So it does, like, this isn't like Earth, where Earth has a liquid surface. Europa's surface is a solid, it's water ice. But underneath that ice, we're pretty certain eventually it'll turn to liquid water and there'd be a liquid water ocean covering this entire moon. And if there's liquid water, who knows, maybe there's life on Europa underneath all that ice. Ganymede is the largest moon in the solar system. It's actually even bigger than Mercury is. So as boring as this moon seems to look, it is notable because it's the biggest one in the entire solar system. Next planet, of course, is Saturn. Its distance is 9.54 AU. Its radius is 60,000 kilometers. So also really, really, really big. Not as big as Jupiter, but still really big. Surface temperature is negative 139 degrees Celsius, and the number of moons is 62. It's the second largest planet in the solar system. It's known for its very beautiful rings, of course. It's also made mostly of hydrogen and helium, just like Jupiter is. But what's interesting about Saturn is it's a very windy atmosphere. And that could be why it has these really like stark lines on it, right? Like it looks like it's been kind of combed or something. It could be because the wind is pushing all the gas in those line directions there, although I'm not 100% certain. The winds on Saturn, though, are often over 1,800 kilometers an hour. That's faster than any hurricane or any tornado or anything on Earth. That's insanely windy on Saturn. Now the rings here, they're actually made up of rocks, dust, and ice. What they actually believe is it's possible that it's a broken up moon. There could have been a moon that actually existed there once and then something collided with it and caused it to burst into pieces. And all those little pieces, as they buzz around Saturn, just like what we talked about, our solar system forming like a piece of pizza dough, eventually all those little pieces just became a pizza dough thing and became this big ring. But who knows? They have several theories on that. We don't need to go into all those, but feel free to look it up if you wish. Saturn's moons also pretty interesting. There's a few that are notable. There's Titan, that's this one, this really weird fuzzy one, Enceladus, and Mimas. I think that's how you pronounce that. Titan is actually the second largest moon in the solar system, so it was named pretty well. It has a very thick nitrogen atmosphere. It's quite weird that a moon has an atmosphere like that, but there you are. Titan's a unique moon. Enceladus is another ice world, kind of like Europa. There could again be a liquid water ocean underneath its surface. Even if you look at this, it kind of looks like a big snowball. So who knows? Maybe there's a liquid ocean on that, and who knows? Maybe there'd be life with that. Now, Mimas isn't exactly super interesting, but I always like including it because it totally looks like the Death Star from Star Wars. I don't know how many of you guys have seen Star Wars before. That's a huge coincidence. This moon of Saturn, this photo actually came out after the movie came out. So in other words, it's not like the movie was referencing this. Is that like, that's just how nature is. What a funny coincidence, because it totally looks like the Death Star from Star Wars. And if you don't know what that looks like, Google it, Death Star from Star Wars. You'll see exactly what I mean. All right, second last planet here, Uranus. Its distance from the sun is 19.19 AU. It's way, way, way out there. This is way far out there compared to what all the others are. Its radius is 25,550 kilometers, so quite a bit smaller than Jupiter and Saturn, but still massive. Its surface temperature is negative 197 degrees Celsius, and it has 27 moons. Once again, just like the other two gas giants, it's mostly made of hydrogen and helium, but it also has methane in its atmosphere, and that's what actually gives it the blue color. What's weird about Uranus is it actually rotates on its side. Most planets have their axis up here, and they rotate that way on it. Uranus actually has its axes that it's rotating on the sides here. We're not 100% certain why that is. It could have been collided with something at one point, which caused it to tilt over, who knows? But it is actually kind of weird that way. Now, Uranus actually also has a very thin ring system. The rings go this way. That's not exactly the easiest way to draw it, but you get the idea. So they go, opposite to where those those rotational axes are. The very thin ring system is hard to see. It's not nearly as awesome as Saturn's is, but it is there. So, all right, so last planet in the solar system is Neptune. Its distance from the sun is 30.06 AU, so this is even further out there. Its radius is pretty comparable to Uranus, 24,700 kilometers. The surface temperature is negative 201 Celsius, and it has 14 moons. It's basically a twin of Uranus here. It's mostly the same, hydrogen, helium, methane, giving it its blue color. It is actually even windier than Saturn. It has winds of about 2,100 kilometers per hour, so still very insane. And just like Jupiter, it had a storm called the Great Dark Spot. That's what you're seeing right here. However, it actually disappeared in 1994. We've been able to see through observations that storm didn't last. But when we first saw it, we saw the Great Dark Spot, and we're like, oh wow, it's kind of like Jupiter. No, I guess that was temporary. We don't know how long that thing lasted for. Who knows? But it seems to be gone now. Next up, of course, are the dwarf planets. So our solar system has a bunch of dwarf planets as well. They don't count as a full-blown real planet, but they're still notable. The most notable one, of course, is Pluto, which up until 2006, it was actually considered a planet of its own. Another dwarf planet is something called Ceres, which is quite fascinating because it's actually in the asteroid belt, which lies between Mars and Jupiter. It's not a full-blown planet. Ceres, I believe, is this one, just by the way. It's not a full-blown planet, but it is still pretty interesting because it's rounded by its own gravity. So you think maybe it could be a planet, but it's not. It's just a dwarf planet. Now, many other have been discovered beyond Pluto. There's one called Eris. It's way out there. There's another one. I love the name of this one. It's Maki. That's also way out there. And this one, I believe, is pronounced Haumea. Pretty sure that's how you pronounce that, Haumea. It's also way out there, right? And they're all dwarf planets. This, by the way, didn't say this is Pluto. We didn't get a photo of Pluto until 2015. We actually didn't really know exactly what it looked like. We only had very blurry photos. And Pluto's kind of cool because it looks like there's like a heart built right in there. Oh, see, look at that. Anyway, moving on. So asteroids and comets. There's some other things, of course, in our solar system beyond just planets and dwarf planets. Asteroids are rocky or metallic objects drifting through space. So they're just big boulders drifting through space. Now, some of them could be as small as a few meters wide, so like the size of a car. Others could be as large as hundreds of kilometers wide. Really big. Now, comets are kind of like asteroids, but they're objects that are made out of dust and ice that appear to have long tails of glowing ice and gas caused by the solar wind. So in other words, they're basically just big snowballs flying through space. And they get these really crazy long tails on them because the solar wind from the sun reacts with the ice and blows it away, giving it this long tail as it flies through space, which is pretty cool. Now, these tails, they can actually be as long as millions of kilometers long, which in the whole scheme of space isn't really all that long of a distance. But in terms of people, of course, that's crazy, millions of kilometers long. Now, there's a comet, it's the most famous comet. It's called either Halley's Comet or Halley's Comet. Both of those pronunciations are correct. I'll call it Halley's Comet. Halley's Comet is seen every 76 years. It's like clockwork. It always comes around. So it's notable because most people are fortunate enough to see Halley's Comet at least some point in their lifetime. I have not seen it yet. This actually, last time it visited Earth was a couple of years before I was born. It came around in 1986. So if you do the math on that one, you know what, I'll take care of it for you because that's interesting. 1986 plus 76, it'll come back in probably the year 2062. So mark your calendars. That's all I'm going to say. I think this is the last thing we're going to talk about here. There's meteoroids as well. A meteoroid is a small rock in space, so it's smaller than an asteroid. It could be anywhere as small as a grain of sand to about the size of a car, right? So it's basically just a small asteroid. Now, when meteoroids enter our atmosphere, they burn up and they release a lot of light. When they do this, we actually change their name to meteor. So this is where things are kind of weird. A meteoroid is just something floating in space, kind of like an asteroid. When it enters our atmosphere, it becomes a meteor. We call that a shooting star, just colloquially, right? That's just how we say it in normal talk. So a meteor is as it's blazing through the sky. And if the meteor manages to hit the ground, like this one clearly did, it's called a meteorite. So it gets this little "ite" ending on the end when it actually managed to hit the ground. So you will need to know all three of those terms. So meteoroid is buzzing around in space. Meteor is as it's flying through our atmosphere about to crash down. If it actually hits the ground and doesn't just burn up and become nothing, it's called a meteorite. So that rock that's left over is a meteorite. Anyway, that was a long lesson today. Apologize for that, guys, but there's a few questions I want you to do. Page 400, questions 1 to 9, and then 12. You will have some time in the next class to work on these. I knew this lesson was going to be a little long. Tomorrow's video is just going to be a neat video that I found elsewhere. But aside from that, if you need any help, please let me know.